This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Lecture 11. Today we're going to be discussing polymorphism, abstract classes and interfaces in more detail. And now polymorphism is an important facet of object-oriented programming, and it kind of makes it all work together. In a nutshell, polymorphism refers to the ability to write a single piece of code that handles multiple types of data. In practice, what this means is that it allows you to build a hierarchical structure that allows you to utilize the object within object-oriented programming. So this polymorphism comes from the Greek meaning for many forms or shapes. It's a great way to avoid code duplication. So when you're working with similar types of entities or objects, you can define those similarities in one location and utilize those all the locations that you're using this polymorphism construct. It makes your code far more flexible. It really does speed up the process of actually developing a professional piece of code. Now, we will be looking at three kinds of polymorphism, or Java supports three kinds of polymorphism. Ad hoc polymorphism is something that we've already covered, which is overloading. And if you remember, overloading is where you can change the signature of a method to allow Java to utilize the same command using different data types. It's a very, very useful function to have. Subtype polymorphism is another type of polymorphism, and this is the Liskov substitution principle of overriding. So essentially what you'll have is you'll have a base class or a parent class, and then you'll extend that parent class as a child, and then any part of the base class that you're needing to change or to give a difference to your child class, you simply override that method to enable you to get more functionality. Parametric polymorphism is something that we'll be covering next week when we cover generic, so we will be covering that here. Hopefully throughout this lecture, what I will be able to do is to demonstrate using code examples the means and ways in which we utilize polymorphism into practical terms to give you a stronger and much more controlled means of using object-oriented programming. Now, you've used polymorphism already when you consider the print statement. Now, when you choose print, or system.out.print, and you decide that you're going to print anything from a number float or any of the data types, the primitive types, or in fact any object or any toString, you don't have to specify to the print statement what type of data that you're providing. Instead, what you do is you simply provide the data that you want to print, and Java, the print command, takes that data type that you have selected and prints it out. So it's heavily overloaded to handle all the primitive types. It handles subclasses of objects by calling the toString. ToString uses overriding to print any object in an appropriate way. Now, we've done this many times. Now, the print method tends to have 8 or 9 methods that we can utilize. So essentially calling system.out.print can print anything. Of course, the variable doesn't change how you print it either. So this is a concept that you've been using without realizing it is part of the polymorphism construct. Now, if we look at an abstract class and what an abstract class is, hopefully I'll give you some demonstrations as to how this class is implemented and the differences between it and an interface. If we look at the example that we've been working with, which is the located person, the way that a located person reports finding a missing person varies. So if a homed person is found in a home, or a sheltered person in a shelter, or a hospitalized person in a hospital, the homed person will contact them at home, the sheltered person will contact them through a shelter, and a hospital person will contact them through a hospital. Now, located person obviously is an abstraction of all of these. So what we do is we write the principal structure within located person, and then the homed person extends the located person, sheltered person extends the located person, and hospitalized person extends the located person. So let's look at a quick example how this would propagate in something more real. Let's look at a really quick example here. So what I'll do, let's create a few classes, and together we'll program a little structure that gives some meaning or understanding to the concept of an abstract class. Now, I've got this main method, which I've just made to work. It's just a basic main method that does nothing, just simply prints out some value. So what I'm going to do is I'm going to create a standard Java class, and let's just call it person. And by creating a person class, let me get rid of all this junk. What we'll do is we'll give this person class attributes of a person type object, and let's just keep it really basic. So in this case, let's just have a private final string, and we'll call it name. So this will be a variable of type name, so give the person a name. Let's do a private int age. Now I'm leaving the int age to not be final so that it can be altered later. So now that we have our properties of a person, what I want to do is to create a constructor. So we do that by saying public and the name of the class. And then I'm going to give this one the name of name and an integer of age. So when we create a new person, I want you to be forced to give a name and an age. And in this case, we're going to say this dot name equals the name that we've been sent to, and this dot age will equal the age that's been sent. So suddenly we've got now a very basic object of type person. So what can we do with this? This is just a normal class of type person, and it has two properties, both name and age, and it has a constructor that simply sets the name and sets the age. Now, of course, the next thing we want is to have accesses, because I've created this the name and age as private, which means they're not accessible outside of this class. So we need to provide an accessor method for each of these variables, so that we can have this information ready to hand by any class that uses this class as an object. So in this case, let's do a public string get name. This is the standard norm to name your getter or your accessor, get, and the name of the variable. So that's very common practice. And because I'm creating the person in the constructor, I won't be producing setters or mutators in this case. So for this example, I will just get even the age. To keep it simple, I'll just get the age. So we're going to get the name, and all we're going to do is return this dot name, which simply calls this name, which is part of the person object. And we'll do the same thing for the age. So we'll say public, this time it's an int, and we say get int. And my system is very sluggish for some reason. Get int. Anyway, and now we have return this dot age. So we have a very, very basic person class. The person class has a name, an age, which is set during construction using the constructor. And we have two accessors called getName, which gets the name, and getAge, should be not int. GetAge gets the age. And now we have a basic person object. So we call this an object because it has attributes. So you have to kind of join along and pretend it is a physical object or a real entity with some properties that all entities have. This is the agreement we all make, I guess, that it's you have to think of it as an object. The object itself, as I've mentioned many times before, is just simply these two values. Everything else is designed to manipulate and alter or to share these two values, and that essentially creates an object. So we have a person class. The next thing I want to create is an abstract class. Now let's say a person may have different ways of being communicated, similar to what we are looking at with a missing person, but let's just make it a standard person with different communication profiles. So let's make a new class, which in this case we will make it an abstract class, but let's just call it contact. And it's going to be a standard basic class, nothing fancy. So this is the same as the person class, but this one's called contact. First of all, I want to extend person So the next thing we need to do is to create the expected constructor for the person class. So to do this, you say public, you make the constructor for this class, public contact, and in this case, let's take a string name and an int age. And because we're extending person, the first thing we have to do is provide the parameters that the person class expects, which is a string and an int. So let's provide a string and an int to that, and we do that by calling the super, which simply calls the constructor from person, and we provide name and age, which is a string and an int. Now, so this contact is going to be holding some values that allows a person to be contacted, to get some unique output for the way a person is contacted. Now, let's just, for argument's sake, say that a contact will be contacted through a string value, and let's just call that contact info. So now we have a string called contact info. Let's make it private just to keep it separate from other classes, and then we can use a constructor to access that. Now, at the moment, this is just a standard class, exactly the same as the person class. So the way we turn it into an abstract class is simply by calling the class itself abstract. So we say abstract. Now this class is abstract, which means that we cannot create an object from it. So let me show you what that means. So let's get rid of the abstract for a second. Let's go to the main method and let's consider producing a person. So we can make a person p, call it p1, equals a new person. And I think a person probably needs to have a string. So let's just call the person Bob, and the Bob is 22 years old. So now we have a new person that we've created. Now, if we wanted to do the same thing with contact, and let's just call it C1 for contact 1 equals a new, and you can see that we can have a contact. And the same thing we're going to do is we're going to call this contact Kev, and Kev is going to be 25. And we've got too many parameters there. So now we've got two people that have defined. So you can see if I go to C1, I can see that C1 has a get age and a get name, which it has inherited from the person class. If I was to say system.out contact name is plus C1.get name, when I run this, it should give me the output of contact name is Kev, and we can verify that Kev is the contact name. And we can do the same thing for the age, and the same thing is true of the person. Let's do the same thing. Person name is, and let's just call that P1. So when I run this, you'll see that you have now two outputs, and now you can see that person name is Bob and contact name is Kev. So that's pretty much what you would expect and what we've been covering so far. If I was to change contact and make it abstract without changing anything else, I'm just now making it an abstract class, and we run this code again, so suddenly now we have an error within the code. So suddenly contacts can no longer be instantiated, and that's because now contacts has become an abstract class. Now naturally, because contact has no public parameters other than its constructor, we can't access its object parameters. So essentially, we can no longer use this type of construction to utilize contact. So what we need to do in this example would be to extends, and to give that our contact name. So now by adding extends contact, we're extending contact as an abstract class. We still cannot create an instance of it. So what do? The first thing we need to do is to create a constructor to cater for the requirements of the contact class, the abstract class, And of course, even with that, we have no accessible attributes. So let's just, for fun, change this to public, just to showcase that now we're extending contact. And if we were to simply call upon wherever, oh, hang on, what's the name of the variable? The variable contact info is available to us to print out without utilizing or creating that contact info inside person test. Now there's an error here simply because contact info in this instance is being called outside of a static context. So now we can run this and you can see it does nothing. Why does it do nothing? Because we have this error here. It should print out null because contact info cannot and has not been instantiated when we created the name public test. Okay, let me try and explain what's happening here. In a nutshell, what we're looking at is you have a main method which is part of a class called person test. Person test has a constructor called person test. Because person test extends contact and contact is abstract, it means that we cannot instantiate the contact object, but we still have to provide parameters that's required by that contact class, in this case name and age. And if you go to contact class, you can see that contact class is simply passing name and age to its extended persons. Person requires that you have name and age. It seems slightly complicated, but it isn't. And it isn't complicated because what we're simply doing is we're saying, look, contact is extending person and person test is extending contact. So essentially person test now has access to everything that contact has and also everything that person has. Now person has a name and an age, so we have access to that. And also contact has contact info, so now we have a public access to that rather than doing an access to that. But that still doesn't explain how do we utilize an abstract class. Now the first thing we need to have is some abstract methods. So let's just make an abstract method. Now if you remember, the normal way is to say public something, say for example public string. This is a normal method, right? Let's just call it contact person. That is a normal way of producing a normal method. But in an abstract method, what we do is we change the word public to abstract, and then we remove the body, because what we're saying is, what abstract is essentially saying is, look, I just want you to make sure that you have contact person so that when my code utilizes your abstract class, it is forced to create a method that is unique to your code that will deal with contact person. So in this case, contact person doesn't exist. So by doing that, now what we've done is if you go over to here, you should see that it now has an error. And the error is telling us that because it's abstract, we need to override or implement the methods that now are required by contact. And those methods in this case are the string contact person, right? So here we have string contact person. We have to give this some kind of meaning. So rather than construct a new instance of an object contact, what we now have to do is simply provide the override functions that are created abstractly within the contact class. So now contact class within the abstract class doesn't do anything. Those features that are required by that need to be created by the class that's extending the abstract class. I hope that makes sense. Now, an abstract class differs from an interface in that an abstract class can have its own values, its own methods and its own constructors, and abstract methods. It's far more functional. You can utilize these things in many different ways. The abstract classes are used in tons of different classes available by the Java API. Let's see if I can't drag those up for you. Okay, so this is the API of the interface key listener. Now, this is a standard class that I often use when I'm making applications. And a key listener simply listens to key types. Anytime you touch a key, it allows you to provide keystrokes into the computer without entering return. So like when you press the, T key or the B key, then it listens to that and then provides some form of feedback. And in this, you can see that the methods that are required by this in abstract form are key pressed, which has a key event E, key released, a key event E, and key type, a key event E. So if you extend key listener, you have to provide these three methods that are abstract, and if you don't, you can't use it. And essentially that's how you utilize an abstract class. So in one way, you're kind of saying that an abstract class is simply a tool to ensure that anyone using your class provides unique or bespoke methods or method contents for the methods that you're utilizing. So you provide the method name in the abstract class, you provide the method signature or passed parameters, and the calling or the utilizing class that's using the abstract has to give the implementation of that. They have to decide how and what's going to happen within that context. And what this does is it means that you can generate code without caring what is happening to the code itself. You also have another feature that you may well use, and that would be the runnable interface. And what a runnable interface does is allow you to do multi-threaded programming. Runnable simply runs a second, a third, a fourth application within your application that runs independently on an independent clock. To access the runnable abstract class, you have to provide contents for the run method. So hopefully this provides a really basic construct of how to utilize an abstract class. But to summarize, you create an abstract class by adding the abstract keyword before the class keyword when you're creating the class name or the object. To use the abstract class, you have to extend that class to enable you to override any abstract methods that are within that particular abstract class. So you don't make an object of it, it's simply a template which has other properties. Now, if I was simply to implement this class without the abstract construct and produce an interface, the interface would only have abstract methods and it would not have any functionality of itself. I have an example to show you using a simulated dungeon item game, but essentially that's the nuts and bolts of abstract classes. Now let's go back to the slides. So going back to the located person class, what we'd need to know is what kind of located person we need. There's no general way to define how to contact that located person, but the descendants of a located person must define the contact person, and this is the abstract form. So that's how you enforce that. So essentially you can run code that doesn't need to think about the type of object that it's dealing with. It simply knows that it can call a certain method, and that sort of protects the coding so that you can continue to code and know it'll work. The way that you use an abstract method is to define the abstract methods within the extending class. That way you utilize the actual methods that you need to use, and you also are allowed or given use of all the other methods and variables that are available to the abstract class as well, which makes it less abstract than an interface. An interface, in fact, is more abstract than an abstract method, which is an irony in the naming convention, I think. As I mentioned, the form is to have the visibility, public, private, abstract keyword, type, and method name. So this is the return type, method name, and any parameters, much like you would do with a standard method. This is for an abstract method. The only differences between an abstract method and a normal method is the fact that you have the abstract keyword before the return type, and you must have a semicolon instead of a method body. So you don't give it any curly brackets and any information, you simply cut it off, which makes it similar to when you do an interface. So naturally you couldn't use that because there's no body to execute. That's why you can't use them. Not why, that's part of the structure of how they work. If an instance was created and all the abstract methods are created within the calling class, then you can use all the methods that are available to the abstract class. And so it's not possible to make an instance of an abstract class. You simply have to create the methods yourself using the template that's provided to you. Any abstract class must be declared to be abstract. So if I show you another example, if I was to take the abstract away from there, and you can see I have an abstract method, then it's giving me an error. If I take the abstract method away, the error goes away. So if you have an abstract method in a class, you must declare the entire class as abstract. So the abstract class is an abstraction of a closely related set of classes, serves as a super type for all those classes, so it is a valid type for variables and parameters. Again, you can't create an instance of an abstract class. The term that we use to define a time when you're utilizing an abstract class is that we're creating a concrete subclass. And the concrete subclass is where you're actually providing the values that are required by the abstract class to be used. And of course, any class not declared as abstract is inherently a concrete class. That's the term we use for that. So as we've already covered, any class that extends an abstract class must do one of two things. We implement or override all of the abstracted methods, which is what we've just shown an example of, or you can declare abstract itself, which means that you don't want to implement the methods at this time, and you're going to pass that on to any other calling method, similar to how we did with the exceptions. You can pass on an exception. It's the same thing with an abstract. If you don't want to implement the abstract within the class that you're working on, you can simply pass it on and declare yourself abstract at the same time. An abstract class can implement some, but not all, of its abstract base class's methods. Essentially, an abstract class is a kind of in-between between an interface and a normal class. So it's kind of a combination of both. And one thing, a class that is declared to be abstract is not actually required to have abstract methods, and it usually does. If it doesn't, it makes it rather pointless to declare it abstract because you're losing the kind of functionality. So in essence, it's normally expected or good practice to provide abstract methods if you're using an abstract class, but it's legal not to provide abstract methods. And again, any concrete class that extends an abstract base class has to override the abstract methods that are provided by the abstract class itself. So this is an example that we've already covered in code, and it just simply adds the abstract keyword to our located persons example, which is extending person. We provide an abstract method that allows you to utilize some form of control over what is expected of any extending located person class. And of course, any abstract class can have variables, instant variables, as well as instant methods that you can use, methods that you can use, as well as the abstracted methods. And naturally, you should use constructor chaining. So as we did in the example, if you have a constructor that requires values, you must provide a super keyword to provide the values to that constructor as you move up the hierarchy chain. This is an example of having a homed person is extending the previous class, which is the located person. So this is the located person, which is now becoming abstract. So the homed person is now extending located person, and by doing so has to implement the contact instructions for that homed person. So naturally a phone number or some message or something unique to what a homed person object would be, that is added to the contact instructions. And that is the point. I mean, if you then create many objects that extend your abstract class, and each of those objects that you create has to create the abstract method and in turn provide unique or novel bespoke code for that method. Or naturally, you can then just create an abstract class out of a home person, for example, and provide an abstract method to pass on. The same with a hospitalized person. So this is going through the example that we saw a few slides back, whereby you have to just keep providing the contact instructions because you're extending located person. So if you're extending an abstract class, you have to provide meaning to the abstract method that is being specified by that abstract class. So now each lost person in this example can actually keep track of who to notify when they are found by adding an instance variable, such as making a located person. So this is by creating a seeker and then using the seeker in a for loop. So we can do a for loop propagating through a located person of type seeker, which is a located person. And doesn't matter what type of value is in this array, whether it be a hospitalized person or a home person, etc., then we can still execute the abstract method regardless of the type of object that it is sitting upon, because of the way the abstract method is utilized. So whether this is of a type hospitalized person or typed home person, wouldn't make a difference. You still can check, you can still use the list called principle to utilize the located person object on type seeker in each array cell and execute the same command that you know is now going to be available to you. And this is safe again because located person can't be instantiated, therefore you know that contact instructions will be available within the child classes. So now let's look at interfaces and what they are. Now interfaces are closely related classes that form a type, or loosely related classes that have some form of common capabilities. Generally you can compare two instances of the interface to know which is bigger or smaller, etc. And you can utilize these capabilities in such a way that it gives a tighter control over the abstraction than an abstract method. So they're restricted in what they can do. They just capture common functionality. So you can't create an instance just like you can't with an abstract class. They can have constants or final variables, but nothing else. Where it says an interface cannot have instance or class variables. This is relaxed in Java 8, whereby you can actually have constant variables or final variables. And an interface is far more abstract than an abstract class, in the sense that you simply provide the names and return types and passed parameters for each method that you wish to interface with. And as I mentioned before in previous lectures, that this is kind of a contract between two class bodies, or often two teams. They'll use interfaces to develop broader code, knowing that certain methods are expected and the forms that they will provide are expected, but the contents of those methods are not defined. Now we have a case study or a case that we can look at on how to utilize these tools, and what I propose to do is to code this, but I will code this generally, which is risky in some ways, but I'm sure there will be errors. But it'll be a way of you seeing how things are created in real time. I know it's a little bit sluggish right now, this machine, because it's recording and doing this presentation, which is a bit odd, but we'll see how it goes. So we'll be looking at a dungeon text adventure game, and the idea of this dungeon text adventure game is that we'll have 3 items: a scroll, which is like a parchment of paper, and a sack, which is just a bag made out of hessian, and a carved box. And each one of these items will become a sort of a dungeon item, an item that are within that dungeon, and each one will have unique characteristics that they will have, but they will also share characteristics such as being openable or inspectable. Now, One thing to note is that a Java class cannot extend multiple classes, so you can only extend one class, or each class can only extend one class. Not all inspectable things are openable and vice versa, so neither can be derived from the other, but interfaces allow multiple interface instances, so you can extend one class, but you can implement multiple interfaces, and hopefully this example that we'll work through together will show you how that works. You define an interface by simply using the keywords public, interface, and the name. And just like a class, you define it in a file by itself. If you leave off the public, the interface will have a package visibility. Obviously, private and protected don't make sense because your interface has to be read by others, so there's no point protecting it from other files, because it's the whole purpose is that you can utilize it. The body should contain only abstract methods, so completely just abstract methods, and any constant definitions. All members are implicitly public, so you don't have to put in public or anything else, so you can omit that. All methods are abstract, so you can omit that. You don't have to use the keyword abstract. And all variables are static and final, so you can omit that. So if you use variables, they're naturally static and final. If you use methods, they're all abstract. And of course, method bodies are omitted also. So instead of having the curly braces and some method body, you simply put a semicolon at the end. So you start with public, interface, the name of the class, then you use the curly bracket to encapsulate the class, and then you provide all the parameters that you want to be part of the interface. So the only way to use an interface is, again, to declare at the top of the class that it implements an interface. So where you'd have a public class and the name of your class, you would implement and the interface name, and then carry on with your class as normal. Of course, you have to implement those methods that are part of the interface, so they have to become part of the implementing class, and this is how you override those abstract methods that are there for you to use. And this is important in many structured infrastructures, should I say, such as if you're programming for a mobile phone, or if you're accessing a GPU, you have to use certain protocols, certain expected names. For example, if you're using Runnable, if you're creating a runnable class, which is going to be running some threads, you have to implement the interface run. So you have to use the method run, and you have to define that yourself. If you're creating a thread, the runnable class doesn't know what you want that thread to do. So it tells you that the runnable class will need to run a run method, and you have to implement that run method. But what you do during that execution of the thread is entirely up to you. It's sort of an easy example of why this is important. If you implement an interface, you have to define all the abstract methods, and if you don't, you have to declare the class as abstract itself, which then any implementing class of this class that you're creating would have to define all the methods there, just like you would with an abstract class. Each implemented class is separated by commas, so if you have more than one interface that you're implementing, you have to separate them with commas, and I'll show an example in the dungeon game that we're going to work through. A class may be derived from a base class and implements interfaces by preceding implements with extends base class. So I'll show you with some examples in a moment. You can check to see if a particular object is implementing a certain interface by using the keyword instance of. So you choose the object variable, you say variable space instance of space, and then you give the interface name, and it will give you, whether it's true or not, it'll give you a Boolean return as to whether it is an instance of that or not. It's very useful as well. I'll show you with the example of the dungeon test game. If you do find the interface to be true, you do have to cast the interface type to the variable type, or vice versa, to utilize that. Now, Java should know this, because it's a given that certain interfaces are of an instance of another, but you still have to do this explicitly at this moment, at least with Java 8. So let's look at creating an abstract base class of a class called dungeon item. And this will be the root of the hierarchy of the things that will appear in the dungeon. and it will unite all the classes together in the dungeon. And each item will have a get description. So essentially it'll be a very simple abstract class that provides one abstract method for this instance. So let's get started. Let's see if we can create this in our. Let's start a new project, and let's just make a new class. Let's make a new project, new package. Let's call it dungeon. And inside dungeon, let's make a new class, which we will call dungeon test. And let me just make this a bit bigger. Okay, so now we have a new package called dungeon test. And what we want to do, first of all, this will be the main, public static void main. And this is where we'll test our dungeon items, right? So let's now create a new class, and let's call it dungeon item. I'm sorry this is a bit small. I'll try and make it bigger when it's needed to be. You can see that my text here has changed since my laptop got destroyed. So the dungeon item, we want it to be an abstract class. And in that abstract class, we want to have a public abstract method that returns a string, and let's call it get description. And give it no parameters. So now that's going to be our dungeon item, the main dungeon item. And then we're going to have two types of items that do, sorry, we're going to have two types of activities for each item. So we've got the dungeon item that just has a description of that item. And then the next thing to do is to make a new Java class, which will be of type, I'll cancel that, it'll be an interface. So a Java interface, you click on, and the Java interface first will be inspectable. Ooh, there we are. So as you can see, the only difference here for the interface is that it has, instead of having public class inspectable, it now has public interface inspectable. And for something that's inspectable, let's just give it a string. Remember, you don't have to put in public or abstract or anything, because it just will be. Now let's have a detail intro. And let's say, I'll try and remember the example that's in the slides. Looking closer, you see, oops. So that's going to be the first thing that happens on an inspectable item. If you can inspect it, you want to look closer and see something. And then another string will be a reference to a get detailed description. Now, of course, this is an abstract method, so it's public. Obviously, it's an abstract, so public abstract here, but we don't need that, of course, so I'll remove that. And this will have to be implemented by anything that uses this interface. That's the first thing. So we've done the first inspectable. Let's now do another. Let's do another interface, and let's call this openable. So some objects will be, all objects probably will be inspectable. Some objects will be openable. Openable, and in much the same way, this will have some parameters that are unique to an openable object. Now, if you have an object that's going to be open, you'd want to know if it is open, so we'll make a boolean. Boolean is open. So that's going to be a method called isOpen that returns either whether the object is open or it's not. And we'll also have a setter to be able to set that it's open or set that it's closed, but rather than call it getters and setters, we'll just say that it's going to return nothing, void, it'll be called open, and another one called void, and it will return close. And these will be used to open and close objects that are openable. So what we have is this abstract concept of an interface, so that some objects will be openable, some objects will be inspectable. Oh, that's a bit small, isn't it? So there you go. So we have a pretty simple interface called openable. And the next thing we want to consider is some of the objects that we have inside that dungeon. So let's start with a scroll. So let's make a scroll class. So this is going to be an object that will be of type scroll. So let's just call it scroll. Now, scroll is just a parchment, a piece of paper that's rolled up, usually made out of leather in the olden days, probably made out of some kind of waxy paper today. And a scroll, once it's created, okay, so a scroll will have some scroll text. Now, this is a normal class, right? So we're not going to be making this an interface or an abstract. This is going to extend a dungeon item, and it's going to implement something. So in this case, because it's a scroll, a piece of paper, we're just going to make it implement inspectable so that you can inspect that item. So let's give the item some characteristics. So let's make a private variable. Private, let's make it final so that it doesn't change. Make it a string and call that string scroll text. Okay. So and let's give it a constructor. So we say public scroll, and let's take a string so we can propagate the scroll text. Scroll, this is the local scroll text, and let's just give it this, which is the object scroll text. Scroll text equals, and the local scroll text. Oh my gosh, there you are. So now all we're doing is we're creating a scroll that simply has some text upon that scroll. And to make this part of this sort of abstract polymorphism object, we're going to extend the dungeon item, extenders with an S, dungeon item, and the first thing we have to do, because we're now extending dungeon item, we have to provide all the expected values of dungeon item, and in this case it's get description. So rather than doing it automatic, I'll actually copy that. So what I'll do is I'll take this, I will say, there you go. So now I'll just say public string, and we're going to put the annotation, which is override, over here, and the get description needs to return some form of value, some form of string that gives a description to this text. So let's just say a faded scroll covered with barely, say a faded scroll covered with barely decipherable CPH, decipherable ornate lettering. Right, so that's what the description of the scroll will be. And another thing we want to do is we want to make this scroll inspectable, so that we will, if you remember, we have a detailed intro, and looking closer you see something, and a get detailed description. So let's go to our scroll, and let's now implement inspectable. And again, the IDE gives us an error, and that error is saying that we need to provide the abstract methods, in this case get detail. So let's provide those abstract methods. I've done it automatically this time. So as from last week, we had the throw exception, which we want to get rid of because we don't want it to throw an exception. Instead, the get detailed description will need to have some form of detailed description. So the scroll text will be created when we create a scroll. So let's return a simple string that, if you remember the scroll text in this instance, when we call the scroll text, we'll be providing some scroll text. So the dungeon item, oh no, it's inspectable. Inspectable has a detailed intro, the word detail. So what we wanted to say is return detail intro plus the following words, and these following words will be whatever's on our scroll text. Scroll text. So what we have so far is a very basic, let me just make it a tiny bit smaller. So what we have basically is a scroll item, an object called scroll, which extends dungeon items, so it's part of the dungeon item ecosystem, and we've had to get the description from that dungeon item. And then we're implementing inspectable, which means we have to get the detailed description of that inspectable. So that's how we've implemented the abstract and the interface. So this is the scroll. So now let's make another item. Let's make a carved box. So this one will be a little bit more complex, so we'll try and do it justice. So let's make a carved box that has something on the outside, so it's inspectable, it's openable, and it has something on its inside. So this will give us something quite interesting in the way that we implement this particular object. Now, okay, in fact, let's do a new class, which is going to be a bag or a sack. Let's call it a sack. And sack is actually going to extend dungeon item because it's going to be in the dungeon as a dungeon item. And whatever's in the dungeon has dungeon characteristics. Oops. So let's extend dungeon item. And this one will implement openable. So this is a sack. You're not gonna examine the outside of the sack. It's just a Hessian sack, which has got nothing of interest in it. And I'll just auto-complete what needs to be done here. So let's implement all abstract methods. So these are the get description. So get description comes from the dungeon item. The is open and close comes from the openable portion. So this is from the interface openable. And so these are already created for us. But of course, the sack also needs to have its own characteristics. So in this case, let's make a string of type detail to see what the details are of the sack. And because it's a sack, it needs to hold something in it. So let's have an array of dungeon item, and that array of dungeon item we'll call contents, and that'll be equal to a new array of dungeon item, and we'll give it 0, so it's empty, right? So we'll have to look out for that when we're propagating through it, and we also want to check to see whether the sack is open or closed. So private boolean, and we'll call it tied to see whether it's tied or not, equals false. So the sack, it has a get description. We'll come back to the get description in a moment. But first of all, let's just do the simple things. So if it's open, it means it's untied, right? So let's just return not tied. So we have this tied parameter that is open. If we're saying open, in other words, declaring that it is open, we say that tied equals false, therefore it's not tied. And if it's close, if we're using the closed command, we'll say tied equals true. So now we have is open, open, and close. So these are doing commands, and this one is providing a boolean as its construct. We also are going to need a way of creating a value for detail, right? So let's create a constructor, public sac, and that value of the constructor will take a string, and let's just call it detail. And the detail will simply say this detail equals detail. So pretty boilerplate code. So the get description for now, we'll just return an empty string just to give that some value. So the get description is going to be a little bit more complex because we need to decide whether it's tied or whether it's open. And if it's tied, to give one type of value, and if it's untied, to give another. So for that, we need to have some kind of description. Let's make a string descript equals a something detail, so that would be the name of it. So let's just say a sac or something, or a Hessian, or whatever we want to say, a brown or sac. So we're going to provide a return statement for which is going to be a description of the sac. We will send that in the description later, and then we need to, so we'll return desk like so. Oh. And we'll add to that. So we're going to say get the description is a say brown sac, and then we need to say whether it's tied or whether it contains something. So first of all, we need to say if it's tied, then that's going to mean, you know, we can have that description, and we'll add to that description. So it's plus equals. If you remember, plus equals concatenates a string with another. And let's just say if it's tied shut with a bit of twine. Twine is just a piece of string. So that's if it's tied, it will just do that. And otherwise, if it's not tied, you want to say what it contains. So either it contains nothing. So if it's open, you're examining it, you're getting its description. It's going to contain something or nothing at all. So let's just say that descript detail is going to plus equals and add the keyword containing, and then obviously the something. So I want to put a semicolon if it's got something in it, and no semicolon if it hasn't. So what I will do is I will just simply add to this, and we'll use the inline if statement, if you remember. So if the contents length is greater than 0, then we know that there's something in there, right? So if this contents, and this is a bit small, isn't it? If this contents, oh, it's a bit too big now. It's very slow. If this contents array has got a value in it, therefore there's something in the bag, in the sac. And if it doesn't have a value, there's nothing in the bag. So if it does contain something, if the contents is true, then I want this value to have just a semicolon, followed by the contents that are in there. Otherwise, okay, don't be confused with the double dot. Just look at the construct of this if statement in previous lectures or on online. But this is how it's done. So if it's true, the first element in front of this double dot, and if it's not true, so if it contains nothing, we just want to say, look, nothing at all. So now we have, if it's tied shut with a bit of twine. Otherwise, if it's open or untied, it's containing either nothing at all or something, right? And because what we can do is we use the for loop, the new for loop, which is for, and we're going to say dungeon item, so we can use Liskop's principle and use dungeon item. So any type of dungeon item, and this is obviously extending dungeon item, therefore it's a dungeon item, and let's just call it content of contents, so that's going to be the variable. The item, in this case, if there's no items in there, it's going to say nothing at all, and then it's not going to list through the items because this will have 0 value. But if there is a value there, it'll go through each item in turn and provide us with some form of value to that. So let's say the description is plus equals to /n, make a new line, and we'll put 3 spaces there, and then we'll add the item, which is obviously in the loop, and we'll get the description. And that description should give us the description of each item that's within that get description. And of course, the last thing to do is just, we have it already, to return the description. So that's getting the description of whatever's inside a bag, if there's anything at all, and hopefully it'll say nothing at all. If it's not working, and it will say what is in there. If it's not open, I mean, if there's nothing in it, I mean, and it'll say what is in there if there's something in there. So that's the first thing. Then we also need to have a parameter to add an item to the stack. Okay, so let me just close these down to make things a little bit tidier. So we have our overridden, we have our stack constructor. So just here above this override, I will put in a public void, so it returns nothing, an add item. So this will allow us to put an item into the stack. So the stack has to take care of its own contents. So we'll put dungeon item, an item of type dungeon item. And what we'll do, this is where we get to use that instance of. Now, because we're extending dungeon item, we want to check to see what is this an instance of. Right, so if the item that's inside the bag is of type openable, we want to close the item before putting it in the bag. Does that make sense? So the construct here will be, like, we'll check if, and we'll say if this item that's been added to the bag is an instance of openable, so you give it the interface name. So that returns, if you remember I said it returns a Boolean value. And this is a weird construct, just accept that it works. So I'm going to be casting, because the item will come in as whatever it is, but I want to know whether it's implementing openable. And if it is implementing openable, I stupidly have to cast it as openable first before I can utilize its variables or its methods. So if the item is of type, or is implementing type openable, I want to say cast the item as openable first, then bracket that again, and this time say close. So I can use the close method here. I hope that makes sense. If it doesn't, just look it up. It's just Java should know if it's type openable. It should be able to have access to the close function, but this is just one workaround for that. So the next thing we need to do to add the item is that we need to extend the actual array. So we have an array called contents, and we start off as 0. So we can't actually put an object or an item into a 0-sized array. So what we have to do is we have to manually extend that array by 1 and then add the item to the end of that array, right? So what the way to do that is to make a new array. So we say dungeon item array, and we'll call it new contents. And the idea will be is that we'll create a new dungeon array. New dungeon array, dungeon item array, and this is going to be the size of whatever the contents were plus 1, right? So this will extend to this new contents array will be the same size as the old contents array length plus 1. And that gives us an array that's just one size bigger than the previous. This gives us room to put some object in there of type dungeon item. Assuming there are things already in that array, what we need to do, rather than using, we could use a copy array, but rather than sort of showcase that, I'm just going to do the old-fashioned way of saying let's do it quicker. For int I of I to I less than contents dot length. There you go, I plus plus. So what we're doing is we're iterating through the old array first, because we don't want to exceed that. So whatever the size of the old array is, if there's any size at all, we're going to iterate through it, and we're simply going to say that the new contents of index I is equal to the old contents, not old, the old contents of index I. So we're like for like, we're matching like for like, if that makes sense. And then of course, once we've copied the old array into the new array, the next step is to simply add the new contents to the final value. So the new contents, which is at the contents length. If you remember, the length of the array is the size of the array, but the index of the array is the size of the array minus 1. So the length of the array is actually the size of the array, which is kind of one above the actual index value. So by giving contents.length, it's providing an additional sort of index value to the original array. So if the original array was 1 and I gave it the contents length of 1, then this would be index value number 2 for the new array, because the index value and the length are staggered by 1. Just review the lecture slides if that doesn't make sense, but it's sort of boilerplate code. So now I'm just going to add the item to that, and once I've then so now I've got the old array inside the new array and the additional item inside the new array, and then I'm simply going to convert the contents. I'm going to convert the old array into the new array so that we preserve the naming convention. So now what I've simply done is I've made a new temporary array that's one bigger than the old array. I've copied all the values from the old array into the new array. At the very last value, I've put the new item inside that section, and then I just converted the new name of the array into the old array so that we have that contents. And what we're actually doing here is reassigning. So this isn't really copying it into, it's assigning it as the new contents. Almost like a pointer. So that's pretty much the sack taken care of for now. So we have the tide, we have the add item, and that's pretty much taken care of that. The next thing we need to do is to create a box. So let's create a carved box as our third item. So now we have a scroll, a sack, and a carved box. And it's going to be boilerplate stuff again. This is going to be very similar to the other two items, and hopefully it makes sense. But this one, because it's a box, it's obviously going to extend the dungeon item, and it's going to implement, in this case, two items, which is, because it's a box, it's going to be openable, and it's also going to be inspectable. So you can look on the outside of a carved box to see what's carved on there. I hope that makes sense. So much the same way, I'm going to simply add all the abstracted methods in one shot, so I don't have to create those. We'll propagate, or we'll populate, should I say, all of those values as we go along. So I'll just quickly boilerplate this. So sorry, the close, open, and it is open are going to be exactly the same. If it's closed, then open is going to be false. I don't have an open variable, so let's have, okay, so first of all, we're going to have it's a box, so it needs to have its own parameters. So one of the parameters I want to have is an inscription. It's a box, somebody's carved something on it, and we have a lovely inscription. So this is going to be a string called inscription. The next thing is to have a single item in the box, which will be a dungeon item. So something that can be a dungeon item. and let's call it contents. Start off with nothing, so it's empty. And of course, the final thing we need is whether the box is open or not. Boolean open, and we'll start it off as closed. Okay, so the next thing we're going to need to do is we will need to put a constructor there to give this final value its inscription. So let's just create a public carved box. And this is just boilerplate stuff. I should have done it on automatic. Inscription equals inscription. There you go. So that's now taking care of the constructor. And what I want to focus on now is the, let's look at the get detailed description. So what is the description and what is going to be provided in this instance? So first of all, we need to check if the box is open. We can't look at the outside of it. So let's just, if the box is open, return some value saying, look, shut the box because it's open. So say close the box to inspect it. I hope this is making sense. What I'm hoping this does is showcase how to sort of code in general so that you get some feelings and understanding about how things are developed, and showing you how to use abstracts and interfaces, abstract classes and interfaces at the same time. So if it's open, it will return that. Let's put some brackets on there. There you are. And obviously we need something then, so let's return the detail in general. So let's return a detailed detail intro plus the inscription. I'm not sure if this is how I should be doing this, but let's see how we go. The inscription, put a single quote and then plus the inscription, whatever that inscription will be. So let's put the inscription here and then close it with a single quote. So what I've got there, I don't know if it's not big enough. Let me just make that bigger. Right, so what I'm actually doing here is putting a double quote, a single quote, and a double quote. And the same here, this is a single quote and then closing with a double quote, just so you can see that clearly. So I'm saying return the detailed intro, details, the inscription, and whatever the inscription is. We also need to do the get description. And the description is also going to be a little bit quirky because we need to consider whether there's anything in it or whether there is nothing in it. And for this, we're going to have to work out if there are any contents and if the box is open. So if the box is closed, we can't see whether there's any contents. And if the box is open, we say if open description. Now first we need a description, don't we? So let's look at that. So we're going to say, hey, we're going to provide a string of temporary description. String description. The description will be string description, and give it some sort of introduction description. So like an ornately carved wooden box. Then if it's open, we're going to add to that, so it's plus equals. So we're going to concatenate onto that string, and we're going to say, because it's open, we're going to say standing open to reveal. So far so good. Standing open to reveal. If it's open, we need to decide, has it got anything in there or not? So in this case, we need to say, look, if the contents, this is contents that either has an object in there or no. So this is not a box that can hold many things. It's holding one thing. So let's just say if contents equals null, then we know there's nothing in there, right? So if there's nothing in there, we're going to just simply return or add to that standing open to reveal, and then we can just say that it is empty, right? Standing open to reveal, and let's just say descript plus equals that it is empty. Hopefully this makes sense. And of course, if it is not empty, otherwise, else, we're going to say we've basically got to get the description. And the description, if it's not empty, then we need to say what is in there, right? That's what it is. And what is in there is the contents. And the contents is the dungeon item, and the dungeon item has a get description. So we're going to say, instead of it saying that it is empty, it'll instead say description plus equals, concatenation again. And let's just add a dash, at the end, so to reveal, and then put it on a new line, 4 spaces, just for luck, and then we say the contents and call its description. Contents dot get description. Now we could have used the toString, you know, instead of get description, but just for completeness in terms of describing how we access these different parameters from different locations, I'm following this route. Okay, so now we're checking if the box is open. We're checking if there's anything in there, and if there is anything in there, we're going to get the description of what is in there. Otherwise, we're going to say it's empty. But if the box is closed, we want to say something too. So let's say if the box is closed, let's say that it has some fine runes on the cover. So these are sort of symbols. Let's say that the description plus equals with fine runes on the cover. Now we've got the description that will decide or give us some feedback. Even if the box is open, it'll be different to if the box is closed. It'll be different to if the box is empty, if the box is full. And of course, the last thing to do is to return that description so that this get description actually gets the description of this box. I hope that makes sense. So the only thing left to do now is to create the actual main method that we started at the beginning. So the main method is the dungeon test, right? And what we need to do here is to basically provide some form of structure to showcase what is happening in our objects. So the first thing I want to do is to create a method. So we'll call it a public, no, we'll call it private. A private method that shows what's inside a box or inside any object. And this is where you're going to see now the kind of excitement of using these facilities. Now, if you remember when I was creating all the objects, you automatically create the get description and get these overrides. So they're automatically created, right? And also here you can see that these overrides are automatically created, so they have to be there. And again with this, all these overrides are values that have to be oh, we haven't done this is open. Now, one of the things we could have done is we could have put these values inside the dungeon test and made it do an automatic is open, open and close for all objects that are of type openable. But for now, we'll just follow this protocol. So is open, simply, if it is open, we return, what did we have to return if it was open? So we just return the value open. If we call open, we're telling it, we're commanding it to open. So we're simply saying that it is open. Therefore, we're saying open equals true. And of course, if, oh, we've already done the false. So there's no more overrides, I don't think. Okay, there's no more exceptions. Okay, so now we have all those abstract and implemented methods sorted. So now the next thing to do is to go to the dungeon test, and like I said, we need to now make good of these, right? So we want to make a method that's going to showcase one of the strengths of all this and hopefully ties it all together. So static void, I'm going to use a method called show me, which is going to show me the item, right? So you're going to have a dungeon item, and we're going to call that again item, and we're also going to have a string name. So each item will have show me the string name, and we're simply going to show each item in turn. So what are we going to do? Show me is going to, it's going to print out the name plus a colon plus a colon. Then we're going to put in the item dot description, because every item has a description because they're all part of the same dungeon item. And then this is where I want to show you the instance of. So now we'll check that if the item is an instance, if the item is an instance of inspectable, then inspect it, right? So if the item is an item of inspectable, then what we want to do is we say inspectable ins equals and cast the item to an inspectable object, and in which case we can then print out its detail. Hopefully that makes sense. Right, so this is basically a show me method. The show me method is going to be part of the main method, and every time I make a change in one of my objects, whether adding to another object or not, I'll be calling the show me method and providing some form of unity to this entire demonstration. So in this, so here we're going to basically, let's just create a new scroll. Let's call it scroll as a variable. So type scroll called scroll is going to be equal to a new scroll. And if you remember scrolls, if we go back to the scroll, you'll see that they have a constructor which is expecting a scroll text. So we have to provide that scroll text on initialization. So let's just say, please turn over. Please turn over. That'll be the scroll text, and then let's just call the show me, and we're going to say scroll, and I'm going to call this scroll. So providing a string called scroll. We could change this to implement a toString as well here, so that it could simplify that. But so we have a scroll. So we've created a new scroll, and we're going to now hopefully run it and see what happens. I know this is not live to you, but to me it's a live demonstration. This is dungeon test. Let's run this file. Let's see what we have. We have a scroll called scroll, which I've made as, and the message of the scroll is please turn over. I said, show me the scroll. The scroll has said scroll, a faded scroll covered with barely decipherable ornate lettering. Detail. Looking closer, you see the following words. Please turn over. So that's our scroll. Let's now add a carved box. Let's make a box. Let's make a carved box. Let's just call it box. And that will be a new box, a new carved box. And let's just use the warning, Pandora beware. It's a nice fitting, fearful message. So if you remember that the carved box has the inscription. So the inscription is Pandora beware. So the inscription is basically the string that defines this particular carved box. So this is annoying me up there. Sorry, I'm going to bring it back down. Now that we've created a carved box, what I'm going to do is say show me. Show me. I'm going to say box, and I'm just going to simply add box as the description. And when I now run this, it should have two messages, cross fingers. So now we've run that, and we have a scroll, which describes what the scroll is. A box is an ornately carved wooden box with fine runes on the cover. Detail, looking closer, you see the inscription, Pandora beware. So the next thing to do is perhaps to open the box, see what happens there. So how do we open the box? We call the box dot, we say open, and then let's show me if there's any difference. Show me. Let's do the same thing. And let's run that. Oops. Show me. So you've got the original scroll. You now have the box, an ornately boxed with fine runes on the cover saying Pandora beware. Then I've opened the box. It says a box of ornately carved wooden box standing open to reveal it is empty. Close the box to inspect it. So it's not inspectable at that point. So let's just add some more features to this. Let's add an item to the box. Let's add the scroll to the box. So you say box.add item. I just realized is that I haven't put the add item into the box. So maybe that's something I should have added to the dungeon item, auto openable. In fact, maybe if it was auto openable, then perhaps we should have had an add item here. Which would have made it safer. So if it's openable, in fact, let's do that now. So actually, rather than just for speed, let's just take the add item here from the sack, and let's pop it into this element. Now the difference with this, if it's an instance of openable, close, that's if the item that's coming in is openable. The difference here with this is that we only have one object. So realistically, we don't need all of these copying sections. So all we have to do is if we need to check quickly to say if the carved item, so if contents equals null, then we can add it into the box. So then contents equals item. Otherwise, else, just output, sorry, the box already has, the box is full. The box is full. So now, carved box actually has the add item functionality. So if we go back to here, we say add item, and in this case, the item that we're going to add is going to be the scroll. So scroll, and now I'm going to say show me box. Of course, this code can be easily improved, but I just want to sort of showcase the concept. So hopefully now it adds the item to the box, and then we have, it's a bit messy. So you've got the original scroll, which it says, a faded scroll covered with barely decipherable ornate lettering, a detail, looking closer you see the following words, please turn over. Then you have the box, where you create the box. It's an ornately carved wooden box with fine runes on the cover. Detail, looking closer you see the inscription Pandora Beware. Then the next section is when you open the box and you say, an ornately carved wooden box standing open to reveal that it is empty. Details, close the box to inspect it. Then we say add an item to the box, which is the scroll. Then you check the box and you say a box, an ornately carved wooden box standing open to reveal a faded scroll covered with barely decipherable ornate lettering. Detail, close the box to inspect it. So you can see that we've added we've now added an object to the box, and again, this is all because of the type dungeon item and that enforcement of getting the details, and also the interfaces of inspectable and openable, which allow you to check different things. And I'll just quickly code in something for the sack. Let's just make a new sack made out of brown felt, and let's add the box into the sack. And now we'll have a scroll in a box in a sack, if that makes sense. So let's make a new sack. Let's just call it a bag. Why not? Equals a new sack, and I'm just going to call it brown felt, which is the description that it requires. I'm going to say show me the bag. We're just going to call it of type sack, and just to make sure that's working, because we haven't tested the actual sack yet. Let's see how that looks. Okay, so it's a sack, a brown felt sack containing nothing at all. What are we going to do with the sack? We're going to add into that bag, we're going to add the box, which now has a scroll inside the box. I don't know if this is going to work very well, but let's find out. So let's take the bag dot add item, and have we forgotten to add the item to the bag as well? We have. No, we haven't. We have the bag as an item. Okay, so we're going to add the box to the bag, and then I'm just going to repeat this code here. So I'll copy and paste that, and we're going to run that. Okay, so so we've made a sack containing nothing at all. Then we add to the sack and say show me again. It says a sack. A brown felt sack containing an ornately carved wooden box with fine runes on the cover. Of course, because we put it in, it's shut, you see. So now we have the box inside, which obviously is the object that has also the scroll inside. And let's just close the bag to see what that change is. So let's just say bag dot close, and let's just show what it's like when it's closed. Okay, so when the bag is shut, so the last one was here, so you can see that it's doing everything, and it's saying a sack brown felt tied shut with a bit of twine. Now to try and make this look a little bit tidier, just quickly before we close this lecture, I'll close this example, I'm going to quickly put in little gaps or something in between each one of these. So I'm just going to type in gap, like so, and copy that and paste it here, here, here. So for every command I want a gap, and all I'm going to do is write the gap. I'm going to write a method called gap that just gives me a bit of space, so we can see the differences between each implementation. So what we've got to show me, I'm now going to have a private void gap. And all gap is going to do is just do a system.out and maybe 3 dashes and a dash n, maybe a dash n on either side, so dash n. So 3 dashes dash n. So let's just do that. Let's make it look tidier. Oh, it has to be a private static because we're calling it from a static context. And we'll run that, and hopefully we'll see all this exciting outputs once this is decided to work. Right, let me make it a bit smaller so we can see what we're looking at. Right, so all we've got is a command in between each line, showcasing. Actually, what I should do is just double click on there. There you are. So the first one, oh no, I did want to see what was going on. Anyway, the first one is the scroll, making the scroll, then we make the box, then we open the box, then we add a scroll to the box, then we create a sack, then we add a box to the sack, and then finally we tie the bitty twine, bit off. So then we finally tie the sack together, and that gives a kind of an overview, perhaps, of how we would utilize abstract methods inside Java and also interfaces inside Java, and using that polymorphism, that sort of tying it all together for these things. So going back onto the lecture slides. So the lecture slides takes us through what we've already just covered. So really is just reviewing what I just coded by hand. So this is just going through what I just coded, describing everything. So an interface as well can be declared to extend one or more interfaces. So you can extend interfaces as well as an interface, so that sort of deepens the rabbit hole in terms of the complexity. Now the key to remember with all of this, every part of what I've been showing you, is that when you're coding, choosing those variable names so carefully and constructing the concepts of the objects very carefully and the hierarchy of those objects so that they sit very comfortably in your mind before you start coding is the key to all of this. Because if you don't name things correctly, then the flow of the way that you code and develop these things will get so complicated that it may become very, very difficult to manage. So when you are naming or using abstracts or interfaces, the key will be to name them as such that they form almost real-life type objects, or comparable to real-life objects and the structure of real-life objects. That will make a huge difference in terms of the way that you utilize these. Some of the pitfalls: an interface cannot extend two interfaces that specify the same abstract method with different return types, two interfaces with different meanings for the same signature. So if you remember, you can't go to have just one interface. You just can't do certain things. A class can't implement two conflicted interfaces. It's just the way it is. You can't have things fighting, so you've got to be quite clean with what things are doing. And it's the same problem with inheriting from a class with methods that conflict with the method in interface that class implements. So you just can't combine those with classes or interfaces and classes. Java has some standard interfaces such as comparable that allow objects to be compared. Again, you have to use the compare to object. You have to define that yourself. Generally, when you have an object1 dot compare to in brackets object2, the negative number is if it's less than 0, if it's the same as or positive, if it's greater than, will be returned. You do have to define those. Often it goes on arbitrary values, but you can define those yourself. So if a class C implements comparable and A is an array of C, then arrays.sort A will sort A. I'll let you practice that out. So you do have to import Java util arrays, but of course the IDE should be able to do that for you. You use non-abstract class inheritance if there's a meaningful class with few variations with different ways to do something. Use an abstract class when you have limited variety of types, each with its own way of doing something but no generic version. And use an interface when many unrelated classes should support the same operations. Use the interface when some classes may support several unrelated operations. Interfaces, as I've showcased, can't provide method definitions or instance variables. Now, hopefully this hasn't been too draggy and too long. Hopefully you've been able to stick with it till the end. I really hope that it's been quite clear. Obviously, it's been difficult to present without your feedback. I always value your feedback, but I will open next lecture with options for some feedback. So if you have any questions on this subject, we'll review those at the beginning of next lecture. The next lecture is on generics, and that's another exciting topic, which will be our final lecture. So I'm quite excited to be presenting that, and I'll see you guys on Monday.